Rare earth magnets are the tiny powerhouses that make modern tech actually work. I'm talking neodymium iron boron, NdFeB, the strongest permanent magnets we've ever made. Here's the scale. A smartphone uses grams of them in speakers and in haptics. An EV motor can pack a kilo or more. A direct drive wind turbine can use hundreds of kilos per megawatt offshore. Add up everything. EVs, wind robots, drones, hard drives, headphones, and you see why demand keeps climbing. Now, the strategic part. Around 70% of rare earth mining happens in China. About 85–90% of refining happens in China. Over 90% of magnet making happens in China. That's not just market share, that's leverage when prices spiked in 2010, and again in 2021. Entire supply chains felt it. Which elements matter most? Neodymium for strength, praseodymium for strength, dysprosium for heat resistance, terbium for heat resistance. Swap them out, and you lose efficiency or high-temperature performance. Why do governments care? Energy transition. Defense. Most EVs use permanent magnet motors because they're compact and efficient. Wind needs them for lighter, service-friendly turbines. Defense systems, guidance fins, radar, depend on high-grade magnets for precision and power. The bottlenecks, refining chemistry, magnet sintering tech, a thin pipeline of new mines. Recycling? Still under 5% for magnets today, mostly because products are tiny, glued, and scattered. What's shifting? Australia, US, Europe are funding new refining and magnet plants. The EU's Critical Raw Materials Act targets by 2030, 10% extraction, 40% processing, 15% recycling domestically. Companies are cutting dysprosium use with smarter grain engineering. Some are testing induction motors, switched reluctance motors, but that can cost a few percent efficiency. Bottom line, rare earth magnets are small parts with outsized power. Control the magnets and you influence EVs. Wind, defense at the same time. That's why the US cannot impose trade tariffs on China.